Hello, everyone. Welcome to lecture number 5 on sampling. And if you recall from a previous lecture, under descriptive statistics, we had 4 primary tools for collecting, organizing, presenting, and summarizing data. Sampling is one of those tools that allows us to collect data. So in this lecture, we'll cover what sampling is, why it's useful. We'll look at the difference or differences between random, sometimes called probability sampling, and non-random or non-probability sampling. And then I'll go over the most common types of random or probability sampling, and then the most common types of non-random or non-probability sampling. So what is sampling? Sampling, sometimes called selection, is simply the process of selecting or obtaining a sample from a population. And there's many ways that we can do that. Some of them give us a reasonable chance that we will obtain a representative or unbiased sample, and some of them don't. Don't confuse random sampling with random assignment. So you can say random sampling, and you can use that interchangeably with random selection, but don't confuse it with random assignment. These two, random sampling or selection, are unbiased ways, hopefully unbiased, of obtaining a sample from a population. Once you have a sample, if you have an experiment, one way to place participants or things in a particular group is with random assignment. So random assignment would occur after you've already obtained a sample, whether that sample is probability based or not. Why do we use a sample? Well, to be honest, if you can get the population of data. However, especially in the social sciences where we're dealing with people, the possibility of obtaining everyone in the population is next to zero. And so populations often, especially in psychology, are too large or too time consuming, cost too much money or effort and so forth. So most of the time we rely on sample data, subsets from the population. But if you have access to the entire population, and sometimes populations are small, like the 50-something students in this particular class, then I probably wouldn't need a sampling technique. It would be easy for me to obtain the population. So if you can get the population, you're always better off with it. But if you can't, the reason for sampling is population is just too large, too costly, too time consuming. Ideally, when we obtain a sample, we would like it to look like the population. In other words, we want a representative or unbiased sample. Unfortunately, most of the time we don't obtain that, or in some cases, we're not even interested in representativeness. But especially in research, you would like the sample to look like the population from which it was taken. So what are the different types of random? And now, actually, in this case, what's the difference between a random and a non-random sample, or a probability versus a non-probability sample? Right? So in both cases, you're trying to get a sample, but the goal of random sampling is to get an unbiased or a representative sample from the population. In other words, you want a sample that looks like the population from which it was taken. That's the goal of a random or probability sample or sampling technique. Non-random or non-probability sampling techniques, that is not their primary goal. It would be nice, but in many cases, convenience, ease are of higher importance rather than representativeness. Just because you use a random or probability sampling technique, which does a good job of helping you reach that goal of representativeness, it doesn't guarantee you that you will have a representative sample. And another factor to consider besides the sampling technique is sample size. All things being equal, the more people or the more things you have in your sample, the more representative it will be, provided it was obtained in a random fashion. With random sampling, the very definition, the thing that makes it a random sample of some type, is at least initially, everyone where everything in the population had an equal chance of being selected. And that's the key is initially. With non-probability sampling, each member doesn't have an equal chance of being selected. And if each person doesn't have an equal chance of being selected, then there's the potential for systematic bias. For example, if I want a sample of psychology students at Troy University, I may just use one of my psychology classes. And so I've got 20, 25 students in class. I've got a sample, but there's nothing representative about that sample, probably. It was a convenience sample. And as such, it's probably going to contain a certain amount of bias. It's not going to be, except by chance, a very representative sample of all the psychology students at Troy. For one, it would only contain students in the Dothan campus. It wouldn't contain any nighttime students, which do exist. So there are certain differences. Non-random samples are inherently biased, or they have the potential for that, and they typically do not provide a representative sample. So if your goal is representativeness, then non-random or non-probability sampling techniques are not the way they go. If you want ease, if representativeness is not your top priority, then maybe one of these non-random sampling techniques is the way to go. In fact, they are used far more commonly than the random sampling techniques are. Even though these random sampling techniques have some wonderful advantages, so often ease of use overrides our desire or willingness to achieve that representative sample. So even though you in science you prefer a random sample, most of the samples that we've obtained, at least in psychology and the social sciences, have not been random. They've been convenience samples, a type of non-probability. Instead of listing out and give you a definition of all these, I've decided to try to make these videos as short as possible with as much information, while simultaneously giving you this as much information as possible. With that goal in mind, I'm going to try to keep charts as simple as possible. And this is one that I did not create. You can see I'll give credit where credit is due. It comes from Scribner. But these are the 4 basic random or probability sampling techniques. And as a disclaimer, they all should have the word random in them. So simple random, this should be systematic random, stratified random, and cluster random. But the author just forgot to include that. So a simple random sample. Think of a simple random sample as this hat with names in it. And you mix all the names up. You close your eyes, which means you're going to blindly choose a name. Then you pick in another name, and you randomly choose another name until you've achieved the sample size of interest. So you're randomly choosing individuals. And so a defining feature is on each given draw, every person in the remaining population has an equal chance of being selected. Now, the technical definition for simple random sample is going to be every sample of a given size has an equal chance of being selected as every other sample of a sample equal size. The easiest way to think about it is each time you draw a name or a thing, a person from a hat, each person, thing had an equal probability of being chosen. With a systematic random sample, and again, the word random shouldn't be in here. At first, this seems oxymoronic because systematic is the opposite of random. So how do we turn it into some type of random sample? Well, before we start systematically choosing, if we're using a random, systematic random sample, you have to choose a random starting point. So if this is my population, in this case, we are choosing at systematically every 3rd person gets chosen. The key to make this a random, systematic random sample is your starting point has to be randomly chosen. So in this case, if they wanted every 3rd person to obtain the desired sample size, then they could have randomly chosen a number from 1 to 3 and started at that number. So in this case, they want every 3rd person, they chose a number between 1 and 3, They chose 2 at random. So then you get the second person, the 5th person, 8th person, and so forth. If you randomly chose 1 as your starting point, then you would have the first person, and then the 4th person, etc. And it doesn't have to be there every 3rd person. It could be there every 10th person, every 50th person. Just depends on your desired sample size and the population size. So we just say it's choosing every nth person from a list after randomly choosing a starting point. Sorry about that. With stratified, sometimes you'll see this stratified proportional random sampling. The desire here is to make sure that each subgroup from the population is represented. So for example, if I have, I want some demographics from Troy University, and I know that there are less than 1% of the population at Troy University is from, let's say, Korea, then if I chose a random sample of 50 people, I may not have any people from Korea in my sample. And so in this case, you could divide your group up into these strata, these subgroups, and then make sure a proportional number from each is taken. So in this case, you could say we have males and females. This is pretty representative of higher education today, where we see a lot more females than we do males. So in this case, it chose 2 out of this subgroup and 3 out of this subgroup. And so now the proportions in my sample, let's say 60-40, match what exists in the population, 60-40%. With cluster random sampling, it's very similar initially to simple random sampling. The difference is, instead of randomly, blindly, unbiasedly choosing individuals, you are randomly selecting tagged groups of individuals. So this could represent a classroom, a club, it could be churches, it could be groups. Doesn't really matter what it happens to be, but they're intact for some reason. And so if I wanted a simple random sample of Baptists in my immediate area, I have no idea how to get a list of all the Baptists that live in my particular area. Right, so in order to get a simple random sample, you have to have a sampling frame. And there's no way for me to get a sampling frame for all the Baptists that live within 20 miles of me. But I could get very quickly a sampling frame of all the groups. I could go online and find all the Baptist churches and organizations that within 10 miles of me in 5 minutes. Then you could randomly sample from those intact groups a desired number, just like you would with a simple random. But you're choosing groups at random rather than individuals. And then once you've chosen the group, you have to interview or observe or measure everyone in that randomly chosen group. So these are all random sampling techniques or probability sampling techniques. Even though we don't see the word there, I probably need to update. Non-random sampling techniques or non-probability sampling techniques are biased in nature. A defining feature is not everyone initially has an equal chance of being selected. And probably the most commonly used non-random sampling technique of all is convenience sampling. So in this case, here's the researcher. Who is the researcher selecting for their sample? In this case, just people or things that are convenient nearby, such as just using the students in my class, or type of convenience could be volunteer sampling, where what's more convenient than just having a list where people sign up and show up. So this is probably overwhelmingly the most commonly used sampling technique. Purposive, sometimes called judgment sampling, is where you deliberately select members for your sample based on certain criteria. For example, if I have a study and I'm interested in, let's say, diabetes, and I'm interested in diabetes in women over the age of 60, then I am going to deliberately choose women over the age of 60 who have diabetes for this drug study, this drug trial. So purposive or judgment sampling is selecting members because they meet, based on your judgment for a certain purpose, certain criteria. With snowball, it's called snowball because it tends to grow as it goes downhill, if you will. So in this case, snowball usually starts when it's very difficult to obtain the individuals that you're interested in because you just don't know how to find them. You don't know where they're located. For example, I may want a sample of all surviving World War II vets. Right? Well, I don't know how to get that list. Maybe somebody in the military could provide it or the government. But in this case, what I could do is maybe select one person. And I do know one person, my uncle, who happened to be a surviving member of World War II. And then I could say, hey, uncle, I've got some questions for you. And by the way, do you happen to know some surviving vets? And he may know a couple. And then I find those two individuals. Those two individuals may be able to identify 2 or 3 or 4 more individuals. And before you know it, I've got a network and I've got a large sample that's grown from 1 or 2. With quota sampling is a lot like stratified, except it is non-random in nature. And so your boss may say, go out there and interview 10 Republicans and 10 Democrats. And of course, the people you get to interview is not going to be random. It's going to be the first 10 who are willing to talk to you. And so that's simple quota. But the one that's probably used the most is convenience. But they all have the same problem: lack of representativeness. There's some systematic bias built into these, but they are easy and they're often convenient in nature. So let's do some practice questions. The goal of random sampling is to obtain a representative or an unbiased sample, and that is the goal. So that is true. If you're using non-random, that's probably not your primary goal. An unbiased sample is a representative sample. They mean the same thing for all practical purposes, and that's true, and that's why you conduct a random sample or use a random sampling technique. So true. Random sampling, just give you the answer, guarantees that you will obtain a representative sample, and that is false. It improves the likelihood you will receive a unbiased sample, but there's no guarantee. And so probably the 2 most important things you could do to achieve a representative sample from the population is use some form of random sampling in combination with a large sample. And it's hard to define large because it's going to be relative to the population size. So false, there's no guarantee. Even if you have a large sample and it's random, still no guarantee. With non-probability sampling, each member of the population initially has an equal chance of being selected. That's false. That's the definition of a probability sampling technique or a random sampling technique. If a researcher used students in her class, her course as her sample, then convenience sampling was used. And what's more convenient and sometimes maybe unethical simply to use the students in your class, but that is true. With cluster random sampling, a random starting point is selected before choosing every nth person or thing. And n is just any whole number. Every 5th, 10th, 20th, just depends on the sample size that you wish. And this is false because this is a definition of a systematic random sample. With cluster random sampling, intact groups are used rather than individuals, and that's absolutely true. So instead of reaching in the hat and pulling down names of individuals, you are pulling out names of intact groups such as churches, clubs, schools. That is true. Random selection and random sampling are the same thing. You can use them interchangeably. Just don't confuse random selection or sampling with random assignment. They are not the same thing. A stratified random sample should be used if you want members of subgroups to be represented, and that is true. So the first step with a stratified random sample is to divide your population into various strata, such as males and females, or sophomores, juniors, seniors, and freshmen, and then make sure members from each are randomly selected. Often we do that in equal proportions to the population, in which case you have a proportional stratified random sample. Quota sampling is unbiased. Well, unfortunately, it's not. It is biased in nature. With quota, the people that you get are the people that are willing to talk to you or be interviewed or fill out your questionnaire. So I forgot to click it, but it is false. It is biased in nature. Probability sampling is used more often than non-probability sampling. This is false, despite the huge advantages in terms of representativeness that we gain with probability sampling techniques. They are often difficult and time-consuming, and instead we tend to rely often on non-probability sampling techniques such as convenience samples. And that is the end of the questions. So as always, feel free to call, text, email, set up a Zoom, or I've actually figured out Teams lately. Teams a meeting with me, and I'll be glad to meet with you.